Hello and welcome to Fat Belly Mark's Shed. I'm Stu and I'll be narrating on today's video. In this video I'm going to make an off-centered wall clock comprising of randomly spaced squares and rectangles. The clock is going to be up there between the two boxes above the TV. I used this piece of cardboard as a template. Pieces of paper were roughly stuck to the cardboard to show the outline of the clock. The materials I'll be using are offcuts of Corian and Hymax kitchen work surface. The colours will range from white through to grey and on to black. Mark the corners of each square and measure them before drawing them on the cardboard squarely to one another. This is the material I'll be using. As you can see, some are plain and others have a marble effect. The parts were marked out slightly oversized and then cut out on the bandsaw, ready for machining on the CNC. I hope you watched the video all the way through, and if at any point you wish to make a comment, please do so. I'd love to hear from you. Over at the CNC, I'll show you where I set it up from start to finish to machine a part. I'll use the aluminium block to place the part so that it is parallel to the router's X-axis. Masking tape is placed on the spoil board and on the part, and a layer of super glue is applied and the part is stuck down. As the parts were cut oversized, the tool is manoeuvred into position just inside the bottom left-hand corner of the workpiece. The X and Y axis are then zeroed. The leads of a multimeter set to measure continuity are connected to the cutting tool and a 1mm feeler gauge. The tool is then positioned over the workpiece and lowered onto the feeler gauge. The jog setting on the Z axis is then reduced so that the tool can be moved up in small increments. When continuity is broken and the meter reads open circuit, the tool can then be lowered again to the point where continuity is regained. The Z axis is then set to read 1mm above the workpiece surface. The CNC is now set up to start from the bottom left hand corner of the workpiece. Over at the CAD/CAM computer, a new model is set up to the required size of the workpiece, which is 160 by 45 with the start point set in the bottom left hand corner. Please consider subscribing and giving me a thumbs up. Thank you. I then select a rectangle tool and draw a rectangle around the model. I import a tool template which I have already set up. It contains two tool paths, but I'll only show you one in this instance. I want to cut around the outside of the rectangle with a start depth of 0 and a finish depth of 11.5. The tool is a 3.175mm end mill and the workpiece is 12mm thick. As you can see, the tool path is being drawn around the outside of the rectangle. All that's required now is to save the program to a USB stick so that the tool paths can be loaded onto the CNC computer. At the CNC screen, the program is loaded from the USB stick and the program is then started. As you can see, the X, Y and Z axis change as the cutter follows the instructions in the G-code program. Now the part's been machined, it's ready to be sanded, and I use 600 grit wet and dry for this. That's it in place, only another 14 pieces to be machined. To make the clock a bit more bespoke, I decided to make little cameos of my grandchildren and stick them to some of the squares. This program has a face wizard which is ideal for making cameos, and I'll run you through it. First of all, you open a picture and then draw a line around the head. This line is called a vector, and everything inside it will be made into a 3D image. It then asks for you to locate the centre of the eyebrow and the nape of the neck. You then enter the size you want the head to be, and also the size of the model. The program then produces a 3D image. Because the 3D image has been produced from a photo, there is a lot of noise produced, which needs to be smoothed out, and this is done with a smoothing tool. This can be quite time consuming, but what you need to consider is that the detail of your finished article will be determined by the size of the tool that you use. I'm now going to create the toolpath to be used. Here we're going to machine the whole of the relief with a 1mm ball-nosed end mill. I'm only going to use the finishing tool, as I know that this is able to cut 12mm corian in only one pass. The relief is 7.79mm thick, and I want to leave 0.25mm on the bottom to protect my spoil board from any damage. Press calculate and the toolpath is produced. A simulation of what the finished part will look like is then run. The toolpath is then saved to the USB stick as before. That took 1 hour 31 minutes and 18 seconds to cut out. All that's left now is to cut out the holes in the template and mark up the wall from the template, and then fit the parts to the wall. Please remember, I'm using these double-sided sticky pads to stick the parts to the wall. This has been an enjoyable project, even though I have overcomplicated things by using the CNC machine. I think anybody with some basic tools and DIY experience could produce something similar. I hope you have enjoyed the video, and please leave your thoughts and comments below. Maybe you can even come back and visit next time. Thanks for watching, and goodbye. See you next time.